In this video, we're going to talk about magnetic quantum number and the spin quantum number. In order to do so, I will re-establish that in an atom there are shells, and within a shell there are subshells. The four different types of subshells are S, P, D, and F. We say that a shell is made up of subshells and a subshell is made up of orbitals. It is established and it must be learned off in this way, right? Or it must be learned off by heart, that an S subshell consists of one orbital, a P subshell consists of 3, a D subshell 5, and an F subshell 10. So once again, the S subshell consists of one orbital, the P subshell 3, and the D subshell 5. Right? So in your course of study, we will only be assessing up until the D subshell, but you are to understand that the F subshell has 7 orbitals. Sorry, I don't know why I wrote 10. Right? So it should be 7. And we're going to apply the rule here that an orbital contains a maximum of 2 electrons. Right, so I want to add on to that rule, but first I want to look at the number of electrons found in each orbital. So if the S subshell has one orbital, we're going to find 2 electrons. If the P subshell consists of 3 orbitals, we're going to find 3 by 2, which is 6 electrons. The D subshell has 5, so I'm going to fill in the total maximum number of electrons found in each subshell. I have previously mentioned that no electron has the same 4 quantum numbers. So let's look at an electron in the S subshell, right? Let's say we're talking about energy level 1, and we have 2 electrons in the S subshell. And if these 2 electrons are in the same orbital, how do we differentiate one from the other if they have the same principal quantum number, angular quantum number, or even magnetic quantum number? Right, so we're saying we have 2 electrons in the same S subshell. How else do they differ from one another? This is where I'm going to apply what is called the spin quantum number, and it's really describing the spin of the electron. We say that an orbital contains a maximum of 2 electrons of opposite spins. This means the 2 electrons which are found in the same subshell must be of opposite spins. So I want to go on just to call it a little note about this Pauli exclusion principle. So really basically it's what's here, which is an orbital contains a maximum of 2 electrons of opposite spins, right, such that no electron, or no 2 electrons, has the same 4 quantum numbers.